We will have three topics for the first lecture. I will briefly introduce you the concept of stress and strain and the stress-strain relation. Only focus on the elastic part. Okay, I will skip this too. Here we have students from civil engineering department and from the geoscience department or from the Institute of Applied Geology. I really want to highlight the importance of stress on the structural geology. So it's not only important for the civil engineering design, but also critical for the structural geology. So I will skip those. And the earthquake will be the reflection of the stresses. So what is stress? We will in general the stress will be the force divided by area, and we will have two kinds of stresses. One is normal stress, and the other will be the shear stress. I will go through it quickly. So it will be the normal force and shear force per unit area. So it will be very simple. So the normal stress will have the compression stress and tension stress. You will have the strain along the stress direction, but you also have some strain at other directions. We call it the Poisson's effect. You will have some deformation in different directions for the normal stress direction. For normal stress, you will have some lateral expand, and for for compression stress, you will have the lateral expand, and for tension stress, you will have some contraction on the lateral directions. For the shear stress, the stress is parallel to the acting plane for the stress. For normal stress, the stress will perpendicular to the acting plane. So this will be the difference between normal stress and shear stress. And I believe you know it very well. So as you may know, the force will be a vector, but the stress will be a tensor. For example, if you have a particle, then you will have 5 forces acting on this particle, and it's attained some force equilibrium state. You can describe these 5 forces using vector. But if you want to define the stresses within this particle, then it will be difficult to define it via vector. Maybe you already know you can cut any plane and you can find the normal stress and the shear stress acting on that plane. If you change the orientation of the concerned plane, then the normal stress and the shear stress will change. So it changes all the time if you have a different orientation. I want to remind you a very important point right now. When you change the orientation of the plane, it means you change the coordinate system. When you change the coordinate system, then the normal stress and the shear stress will change. So force will be a vector, and the stress will vary for different concerned plane. So stress will be a tensor. You never learned tensor before you enter university. When you are high school students, you pretty know vector. Okay, but you are not know what is tensor. I hope most of you sitting here already know what is tensor. Do you know what is tensor? Any class mention this? Do you know what is tensor? Stress tensor or strain tensor? What is the definition of tensor? Maybe you know, but you are so shy to answer the question. Do you want to answer? What is tensor? It's difficult to describe, right? I will give you a very easy definition for tensor. You know the definition of vector. What is vector? The definition of vector. What is the definition of vector? We always say vector is a physical quantity, have the magnitude and directions. Correct? And right now I want to give another definition of vector. Vector will be a physical quantity when the coordinate system changes. The components in the new coordinate system can always express as the function of the components in the old coordinate system. This will be a vector. This will be the coordinate system transformation, right? If you have a vector in the old coordinate system equals to, for example, 1, 1. This will be the old coordinate system. This point will be the 1, 1. If I rotate the coordinate system counterclockwise for 40 degrees, then what is the new coordinate system? What is the new components for this vector? If you rotate counterclockwise for 40 degrees, then this vector will become, in a new coordinate system, it will become, correct? So when the coordinate system changes, then you can identify the components of this vector. These vectors will, the components of this vector will be function of the component in the old coordinate system. You may still remember how to make the coordinate system transformation, right? How about this? If you change into 1' and 2', this point, this vector will become 1 and -1, correct? So it's only related to the original components and the rotational angle, theta. You can try to use sine and cosine to calculate the new components on the new coordinate system. Okay? What is tensor? Actually, vector is one of the tensor. Vector will be the tensor in rank 1. What is scalar? Scalar is a tensor. Scalar is a tensor with rank 0. Stress tensor is a tensor with rank 2. Okay? So how many components exist for a tensor? For rank 0, it will be how many components? It will be 1 component for scalar. It's a tensor with rank 0. How about vector? Vector will be a tensor with rank 1. How many components exist for vector in 3-dimensional? It will be 3 components, x, y, z. How many components exist for a tensor with rank 2? You will have 9 components. Stress, strain, they are the tensor with rank 2. So you will have 9 components for stress and for strain. Of course, only 6 components are independent. Because of the stress tensor and the strain tensor is symmetrical. They are symmetrical tensor with rank 2. So totally you have only 6 independent components of that tensor, of stress tensor and strain tensor. Okay? So I hope you already have some clear idea about what is tensor. And please remember the most important things for the definition of tensor. What is tensor? Tensor means a physical quantity where the components in the new coordinate system can be expressed or is function of the components in the old coordinate system. What is stress analysis? Actually, stress analysis is solely coordinate system transformation. Okay? In Chinese, 什么是应力分析？应力分析充其量不过就是坐标转换。You trying to answer my question here. What is Mohr circle? Mohr circle trying to help you to conduct the coordinate system transformation via graphically approach. Understand? I hope you can connect all of the things together, including strain analysis. It's the same. It's coordinate system transformation. Okay. I will quickly go through this. You will have 3 principal stress. If you don't have the shear stress at the horizontal plane and in the vertical plane, then you can evaluate the stresses. If the stresses is the same for water, for example, you will have a hydrostatic pressures. Then you can only use one scalar to express the stress tensor, because you will have only one identical principal stress, and all of the normal stress at the different direction will be the same, and you will have no shear stress at any plane if it is isotropic stress, or it's hydropressure. You will have no shear stress because water cannot subject the shear stress. Okay, for soil or for rocks, you will have the anisotropy, stress anisotropy. It means the principal stress could be different in different principal stress directions. So we always want to know, for example, the normal stress and shear stress acting on an inclined plane. So you trying to use more circle to help you to analyze the problem like this. You want to know what is shear stress and what is the normal stress acting on an inclined plane. Okay, so this will be a typical cases for stress analysis via Mohr circle. You will have principal stress direction on horizontal and in vertical directions, and you have only principal stress equals to 200 kPa acting on the horizontal plane, and you will have the minimum principal stress equals to 1 kPa acting on the vertical plane. So you will have, because it's a two-dimensional analysis, then you will have only 4 components for your stress tensor, right? This will be the dimension. If you have a dimension of 2, and with rank 2, you will have 4 components for two-dimensional stress. So the two-dimensional stress, you will have the stress tensor like 100, 0, 0, 200. I simply express using matrix. Actually, you don't really need the matrix. For tensor with rank 2, you can easily to express via matrix. But if you want to express a tensor with rank 4, then you cannot write like this. You cannot imagine, right? It's a bit difficult for you to imagine, but it's a 4-dimension. You will have, if you have a tensor rank 4, like the compliance tensor or the stiffness tensor, you will have 81 components for that tensor, and you cannot write it in a matrix form. For 2 dimension, but no, for matrix, for the tensor with rank 2, you still can try to express it via matrix. Okay, so I want to know what is the normal stress and shear stress acting on that plane. How to solve this problem without the help from Mohr circle. You can starting from the very beginning. You can try to solve the equation for the force equilibrium. Then you can solve this problem. But please remember, it's force equilibrium, but not the stress equilibrium. So you can try to multiply the normal stress times the acting area. Then you will have the forces. You have 2 forces. You have 2 equations. One is the force along x direction will equals to 0. And the other equation will be the force acting on the vertical direction equals to 0. Then you have 2 equations. Right now you have 2 unknowns. One is normal stress and the other will be the shear stress. So you can solve the normal stress and shear stress very, very quick without any difficulties. I will quickly go through this, and I will not try to derive the equations because you can easily understand. But the only things I want to remind you, every force needs to times the length of the acting area. For example, this equals to 1, and the length of this equals to 1, and the length of this will equals to 2 square. So you can calculate the force equilibrium, and you can derive the sigma n equals to 150, and tau equals to minus 50. Minus means the direction of the shear stress is clockwise, because the counterclockwise will be positive. Please always remember the definition of the sign. For my analysis, I always assume the counterclockwise equals to will be the positive. So if you have a negative value of shear stress, it means the direction will be clockwise. This will be a general case. The previous case will be the 45 degree. Right now, it will be a general case. The inclined angle for the plane have an angle with the vertical plane equals to alpha. In this case, you can always solve the sigma n and tau from the force equilibrium. Again, the force in the x and y direction equals to 0. Then you can solve the normal stress and you can solve the shear stress. Again, normal stress, shear stress. You found these two equations can be combined together to become an equation for a circle. Like this, right? And move the x0 to the left-hand side. You can write a new equation like this. This will be Mohr circle. What is Mohr circle? Mohr circle is a graphically illustration for a stress tensor. Right now, here you draw a Mohr circle, then that Mohr circle will be a stress tensor. Can you understand that? This Mohr circle will equals to a stress tensor have 4 components. And you can illustrate it via graphically method. Okay? So what is Mohr circle? Mohr circle is a combination of all of the possible normal stress and shear stress at the different coordinate system. When you change the coordinate system, then the normal stress and shear stress will change. And all of the combination, all of the possible points connect together, it will be a circle. Why? Because force equilibrium tell you the results. Okay? I will stop here and take a rest.